Hey everyone, welcome to the beginning of the afternoon. Really excited to be here with you all talking about open innovation in AI. One of the things that we think about AI, what we don't think about is how it's inherently a human technology, right? It's like we humans are building this. It didn't just come out of the ether. It wasn't discovered in outer space. And so the things that we put into AI systems and models, like our own biases and our own weights and the way that we think about things, are then projected back in the models. And so we're going to dive into that today, how different orgs are thinking about that, and what we're building and what we think it will look like in the future. So I'm going to kick it off by introducing myself and letting my co-panelists introduce themselves, and then we'll dive in. I am Rachel Horn. I am with a group called Filecoin Foundation. It is the other big tech topic of the day, which is a blockchain project that's based around decentralized storage. So it's an alternative to big centralized storage platforms with thousands of participants around the world contributing storage capacity, storing their data, chopped up and encrypted all over the world. No central organization at the core. So I believe deeply in this decentralized open architecture of technology. And critically, our technology is really awesome when we think about decentralized compute and AI, because we offer these amazing resources and capacity for open source innovation and for AI. And so let's go down this group. I'd love, tell us each who you are, who you represent, why you're here, what excites you about AI.
Starting with
you, Polina.
Okay. Hi, my name is Polina. I run the AI policy shop at Meta. And what drives me to be here and focused on open innovation is the open source community and the fact that we heard across the board today about the risks and the benefits of artificial intelligence. And I think it is right now, this very specific moment, that all of us need to be working together, not just on writing the policies, but on actual execution. And so bringing the technology out into the open so people can innovate together, so they can find vulnerabilities together, that those vulnerabilities can be fixed. It also raises a lot of the questions that society has on these topics, and it's easier to also bring up a lot of these questions when you build out in the open. So I've been doing AI for a long time, and my focus has always been AI accountability and transparency. And what is more transparent than open innovation?
That's good. That's a good line. My name is Ariana Fowler. I am the head of research at a company called Equity Lab. We're about 2 years old. We recently came out of stealth in December at COP28 with a launch of one of our products called Climate GPT, which we created with an endowment, the Endowment for Climate Intelligence. We use Filecoin, but ultimately what Equity Lab does is we build responsible tooling for AI using cryptographic technologies. We are developing on open source standards. We're developing open source toolkits. So open innovation is critical, but we also believe in progressive decentralization. We think that transparency and openness should also take into account trust and safety, which was discussed on the last panel. But we're very excited to be here and to be included. So thanks, Seed AI.
Hi, I'm Malo. I'm the CEO of the Machine Intelligence Research Institute. Miri's been around for over 20 years now. I've been there in some capacity for just a bit over 10 years. Miri's main focus has been kind of, looking at if the field of AI kind of actually achieves its goal that it was founded on, of building kind of truly, intelligent AI systems. What is kind of the radical, potential upside of that, and how can we harness that to actually kind of make the world much more prosperous. I think kind of if we succeed at doing this right, we'll look at the course of human history and there'll be like a bunch of times where things were kind of pretty bad, and then we had the Industrial Revolution and things got a lot better for a lot of people, but not everybody, and then there'll be kind of like actually cracking AI, and I think that'll make the Industrial Revolution look like small beans. Creating very powerful intelligent systems, I think, brings with it a bunch of risks. And so we're also looking at, what do we actually have to do to make sure that we can build those systems in a way that will be reliable, that we can kind of have very powerful intelligent systems and harness them for good and not have, catastrophic or existential outcomes as a result of that. And so we do things from awareness raising to research on these subjects and a bunch of things. And with the discussion over the last year kind of exploding into the mainstream, shifting more to talking about it with the public and figuring out how we're going to navigate this as a society. I think it's a big global problem.
Great. So you
challenge.
used a word there that I've been thinking about for the last couple of days, which is harness. This is a tech policy group conversation, a lot of faces that I recognize from DC. I would love a show of hands of who watched the State of the Union on Thursday. Okay, good. So I think more than the average group. So it was the first time in a State of the Union address that a president has mentioned artificial intelligence. And it was 2 lines. It was short, but that's 2 is better than 0. And President Biden said 2 things. He said he talked about voice chatbots, but he also said we need to harness the power of AI. And so I think about harness as really having 2 potential meanings. One meaning to rein in, and the other meaning to unleash the potential. And you used harness in your explanation, but I would love to hear from you all. Maybe we start with you, Malo. What did you think of the president's speech? Is that what you wanted him to say? What do you want to hear from the administration on AI?
Yeah, so I think, I kind of see the need for both meanings of the word harness. Obviously, we want to realize the potential of the technology and actually be able to have all the applications that we want to make the world an amazing place. But I do think that, harnessing it wisely will mean having to make, difficult decisions and working together as nations and a global society to figure out how to best use that technology. And that will require making, tough, challenging decisions about which technologies, as AI develops and becomes more powerful in general purpose, which things should we be doing in the open, which things will we have to find creative ways to harness the open community while not necessarily having everything out in the open, making sure that we're building the right understandings of the systems so that we're actually confident that they'll work the way that we intend, and not building systems that we don't sufficiently understand if they're powerful until we're able to do that. And so, yeah, I think it's a big, complex challenge, and we have to do the kind of full spectrum of what harness means there in terms of how to navigate it wisely in that way.
Yeah. Anybody else have a?
Just wanted to call back to some of the discussions that happened today already. I mean, we have NIST, which is doing incredible work in advancing the state of the conversation on artificial intelligence and has been doing that so for years already. So there's so much opportunity right now for research and for evaluations and for understanding what are some commonalities and some common things that we should all be measuring for so that we can understand every type of risk, or at least the highest risk areas that are most important to us. And so the risk management framework that NIST has put out has been extraordinarily helpful in kind of framing the conversation, both at a system level and understanding the risks at model training, at fine-tuning, at deployment, and also at contextual level, and that at the end of the day, end uses really are important and matter for assessing the risk. And so that's, and as you said, there's going to be general purpose systems, and there are already general purpose systems, and those general purpose systems will be used across the board. And so how can you balance that?
And the one thing I would add is, Catherine Tai spoke about this earlier, but maintaining a competitive advantage, I think, does necessitate open source to a certain degree. Innovation happens at a far faster scale and pace when things are open source. And so I think Biden mentioning that, I think you can't really have one without the other, of course, within certain bounds.
Mm-hmm. So let's dive into the open source, closed source, sort of tension around AI, right? So 2 weeks ago, a big group of us were in Denver for ETH Denver, which is like a big blockchain and crypto event where all the different layer 1 protocols come together, talk about what they're building. And at a blockchain conference, AI was the topic of the day. And all of these different companies on the show floor, or all these different projects on the show floor, were showcasing how their technology intersects with AI. And, decentralized compute and all different things like that. But the big thing was this debate about whether code should be open and anyone can hack on it, or whether this technology is so powerful that we need to start with closed systems, or where is that line that you draw between the two? So I know that this is something that Meta thinks about quite often. So how do you think about this?
So I think the open and closed debate is a spectrum. It's not zero sum, so it's not like either open or closed. Meta's been in the AI game for a long time, and we have our ranking and recommender systems, we have our classifiers, we have our ad systems, and no one is talking about open sourcing some of those. At the same time, we're also in the business of open source and have been for years, where PyTorch has been released open source, and that has become the platform for developers over the last 5 years, and it's been incredible seeing how much open source technologies, especially in the AI space, have enabled innovation. We also have the FAIR team, the research team in our company, who really relies on open source and releasing their models into the world so that they can get interrogated and expanded upon. And you could see some of the advancements in computer vision that have been made possible by open source. For example, where we went from AlexNet 10 years ago to now we have Segment Anything, and you can take a photo or a video of anything in the world and it can segment it in such amazing ways that you can use it for radiological use cases, you can use it in medical use cases. So, and downstairs we have demos that show how our Llama 2 large language model that we released last summer is already deployed in Metatron, in medical use cases, and within our technologies already. So there's just a lot of advantages to releasing it, and there's also a lot of things that we've seen recently where we released Llama 2, certain vulnerabilities were found across large language models that were open source, and using those same techniques, then those same vulnerabilities turned out were found across closed systems. And those issues and solutions would not have been able to be found without open source. So right now we see a huge opportunity and lift in releasing this for developers and researchers across the board. But of course, we're also really eager to contribute to the evaluation space to understand, is there a line that we shouldn't go past a particular way?
Yeah.
Yeah, I mean, kind of adding on to that, I totally agree. You know, there's a spectrum here. It's not a binary, and I think it's also important to kind of like look at the different categories of things. You know, there's the open source analogy. You know, can mean a bunch of things. I like this panel is more about, you know, open science, where, you know, there's the whole question of open data sets, which I think like is robustly very useful and good. There's opening up architectures and how people are actually training AI systems. I think there are different sets of considerations about that. There's open model weights and the you know, benefits and challenges of open sourcing those types of things. I definitely agree that, you know, there's a bunch of work to do, and we'd like the broadest community of people, you know, academics and researchers and independent people, to be able to have access to models, to be able to actually do the important work of finding those vulnerabilities, you know, improving safety stuff, better interpretability work, and that sort of thing. And so to the extent that we can do that, I'm super supportive of that thing. The thing that I also do have my attention on, though, is, you know, as there will always be many models who I think will just be like robustly good to open source. You know, Google had, I think it was GraphCast, their state-of-the-art AI weather modeling software. That's great. Let's get that out there. That's just making the world a better place. I think a bunch of the applications of Llama 2, same thing. You know, people are building on them, making cool products, making, you know, more insight into how to make these AI systems safe. When I'm looking forward, I'm looking at, you know, as we create more powerful general purpose systems, they're approaching more and more human level. These systems will have lots of very powerful capabilities. And I do think we have some challenging questions to ask ourselves about what it means to put those very general purpose models out into the world, especially when we're thinking about open model weights where, you know, companies like Meta and others can put a bunch of work into making those systems, you know, helpful and harmless. But if people can be doing things like fine-tuning those models to take away those properties, there's a bunch of open, interesting research questions, and can you create an AI system that can be, you know, opened up in that way while having some capacity to not be arbitrarily fine-tuned? I'm interested in people in the open source community and in general, like pushing on those angles. I also think we might have to consider some kind of interesting third options where as these models get more capable, and there are some questions about whether it's the right decision to put them out into the open domain, whether there are some creative solutions. I'm very interested in the NARE, the National AI Research Resource, where this might be an interesting third alternative where if there are, you know, big models that might have lots of beneficial applications in society and we want more people to be working on them and improving them and doing more safety research, whether we can create a large public resource where those models can be made available, where researchers can engage with that, where we can experiment with structured access regimes that actually still let people work with the model weights while not just having the model weights be out in the world, because that's the thing that we can't take back once we do that. And so I'm very keen on talking with people in the policy space and seeing how we can kind of think creatively about how we navigate those challenges. Because I think at some point we're going to have to navigate a tricky question, which is, man, this model can do a lot of stuff, and putting it out into the world might mean that someone who's malicious or incautious, who might have, we might have some misuse concerns, might be able to have a team of, superhuman hackers in their basement. And there's a bunch of, offense-defense questions, and the world can become a pretty wild place. And so that's where I have my attention.
So what are you looking for? Like, what will be a sign that we're approaching that point of like a potential, a danger zone?
Yeah, so back to what Paulina was saying, I think that, I'm very excited about a bunch of the work people are doing in the evaluation space, in the testing space, actually being able to get a more concrete grasp on what are the capabilities of these models, and doing the thinking now and setting up the frameworks now, trying to think ahead what would be some kind of thresholds where we would have to step back and ask some questions, do some more research about those types of things. And so, yeah, the more, robust evaluations we can be doing to actually understand those capabilities, the more research we can be doing now to figure out how we can potentially, open those things up while not being arbitrarily modifiable. Like, those are all things I think are super important priorities today that's easy for everyone to get on board with.
Just a couple of plugs. So one, ML Commons is doing a lot of significant work in advancing evaluations and consolidating around evaluations. So I think it's really important for any of you here, if you're developers or work in the industry at all, including policy, to get involved through ML Commons, because it's lovely to have a place for those kinds of standards who can then inform the US Safety Institute, the UK Safety Institute, et cetera. And then the other policymaker that's doing a lot of wonderful work on evaluations is actually the Singaporean government, and IMDA has recently published a taxonomy of evaluations and what it is that they're testing for, including the existential type risks and emergent behaviors, which are all very interesting ways to start thinking about how we will be able to test for those types of behaviors. And tool use is another really important thing. And as you're doing these evaluations, one of the things that's really important to remember is the threat model. And so you kind of indicated that a little bit right now, Mala, but there's the threat model of a malicious user, there's the threat model of a person that just messes up, and that's a really important threat model because that's probably the majority of the types of threats that we're trying to avoid. And then there's the just regular user, and how do you make sure that you build for each one of those groups, where for the malicious actor, you're trying to mitigate your models and your systems against the worst of the worst use cases while also enabling the best use cases as well.
So let's talk use cases. Let's bring in Equity Labs here. How are you thinking about open source, closed source, and talk about how that informs the work that you're doing?
Absolutely. Well, actually, Climate GPT is trained on Llama 2. So we have a demo downstairs if anyone's curious to check it out. It's a task-specific climate large language model. And I think this is a great use case for open source technologies, right? We had a model that we were able to start with that, all of the great work that Meta did in preparing what we think is a responsible foundational model, we were able to go and quickly spin up a new model. And we were able to, we did it with several of the sizes, 7 billion and 70 as well. And for us, I think licensing is really important. So we work closely with Creative Commons. And so if you're familiar with open source licensing, if you've heard of CC licenses, that's Creative Commons. And I think that's where the kind of non-binary conversation around open and closed, kind of comes into play, because you can actually differentiate how you want your model to be used, and how, even if you make it open, you can say for certain reasons. And the Llama 2 license also is a great license. I think for us, open data is really important, and so we work closely with Creative Commons in that as well. Their open climate campaign and their open research work, because while the architecture of the model is critical, what it trains on is, I would say, maybe even more critical, and especially right now we're talking about data privacy and confidentiality and bias, and so we want to make sure that the technology that we, the technology that we create allows you to see how a model is trained, demo downstairs as well. However, if there's a part of that that's closed, it's still closed. So if there's a data set that isn't open, you can't go in and interrogate it any more than what's available. And so for us, having things open at each step of the way is very important. However, someone earlier was speaking about confidentiality, for sensitive issues like healthcare or, national security. Obviously, we don't want to make those things publicly available. But yeah, I think for us, we think of open source as kind of the grassroots way of accelerating technology adoption, as opposed to like a top-down regulatory mandate or an enterprise mandate. Some of the most powerful tools, including some of the internet, a lot of the internet, has been individuals just kind of tinkering in their spare time and then collaborating. So.
One of the things that's also really important to remember is that we want to enable global use of these technologies, and so there's a couple of things that I wanted to bring up. For large language models, we know that most of the large language models work really well in English, and then they do not work so well in other languages. So we're investing a lot in those spaces. And at the same time, we're also seeing that open source contributes to low resource languages and not even low resource languages being fine-tuned on the basic foundation models to work well in languages like Tamil and Japanese in the case of Eliza, and Mary Talk for Brazilian Portuguese. So there's a lot of different use cases that we're seeing excel, and so we're also investing in multilinguality right now and being able to test how well the models perform multilingually, especially given the alignment problems that we've also heard about so much. How, when you build a large language model that does work in other languages, how do you ensure that it measures just as well for the types of issues that you're measuring before you release the model? And then the other thing that on data set fairness, I think it's really important for us to recognize that there is not great representation within image data specifically for a lot of communities. And so one of the projects that we worked on is Casual Conversations version 1 and version 2. So it's a large it's a large data set that is used that can be used to measure data set fairness. So anyone can use Casual Conversations versions 1 or 2 to assess whether the underlying image data that they have underlying their models has significant representation, statistical representation, and if not, then steps can be taken to amend that. Because we do think that it's really important to have different ages represented, different skin tones, different ethnicities in the case of video as well.
So this is great, and I want to dive deeper into the inclusivity conversation, but before we get there, I think we need to sort of level set just for a moment about, we've sort of thrown about some words that I think maybe not everybody is super familiar with. So we talked about weights and biases, and we're talking about data provenance. So, let's just start by sort of explaining what we're talking about when we say those things regarding AI models, and like what goes into creating those models and how does it impact outputs. Who wants to kick us off?
I mean, so, I can riff off of the thing I said in the previous answer where, you guys will have other things to add to this where, I think we want to be clear about the different categories of things. So there's data sets and data provenance, there's model architectures, there's model weights. I think all of these things have different considerations. There's also tooling. To the extent to which people are developing better practices for training models that make them, more reliable and more interpretable, that those tools are also a different component of the whole, open source, open science thing. And so, if we want to get into the terms people don't know, open model weights are actually, giving the world the access to be able to run the models themselves and change them and actually modify the models. Open architectures would be actually, providing people with the source code that allows them to train the model for themselves. I think open data sets is pretty self-explanatory. So that's some level setting there. I don't know what you guys want to add to that.
So a couple of things. So there's open data sets used for pre-training and then data sets that are used for reinforcement learning and fine-tuning. So there's different types of data sets, and both are important because these models are massive and they involve a lot of self-supervision, and then they do need to be supervised to some extent. So the one thing that we worked on over the last year that I'm particularly very proud of is our responsible use guide, and it kind of will walk a developer on the how-to steps of going from data into the actual final use case of the model, and how to do so responsibly. So how do you actually get the data sets that you need and clean them up in a way that it will accomplish and be fit for your purpose? How do you create reinforcement learning data sets? How do you then build a model on top of that? How do you create policies that you don't want the model to be able to do certain things? Then how do you code for those policies? And then how can you also think, the other thing that we think about is like end-to-end system level mitigations, because the mitigations don't exist they exist at every level, and some of them are more effective at different levels. So the other thing that's really important to think about from an end-to-end system is that you also want to think about classifiers and mitigations at input filtering, output filtering, so that the end product that a generative AI model is putting out into the world is something that you want, and that you intended for. Or in the case of open source, that generally it's pretty open, but you're giving your developers tools for them to be able to mitigate using those concerns. So in our case, it's a tool called Purple Llama where you can do certain types of evaluations and then certain type of classification. But it's a whole gamut of things that can be released openly, and it's also really important besides that to like also help people understand what they can do with those weights or with the data going forward if they do receive it from a third party.
Ariana, tell us sort of what are the potential biases in climate science that you need to think about?
Oh, a lot. A lot. Climate is a very contentious subject, shockingly. So one of the things that we did with researchers actually there's a collective of researchers that created a system to classify climate mis and disinformation called CARDS. And they already have existing research, and what we did is we created a new classifier, a new benchmark, that will allow you to assess if a model is spewing, a large language model specifically, is spewing climate mis and disinformation, and we applied it to our model as well. Our model card results are also publicly available. But I think mis and disinformation is probably the most like severe, or I should say pressing bias, just because it's like, is this true or not? And a lot of climate science is rooted in fact, and just meteorological like data and statistics. However, there's a lot of sentiment and an opinion around what's causing it. I think another thing that we are working to address is around data sets is inclusivity and perspectives, because a lot of research, so you have an issue when you're ingesting data. If you're ingesting just academic research papers, we use the IPCC, which is a UN body that creates reports around climate. They're part of the COP28, or COP process, I should say. COP28 was the most recent conference. But those are academic UN climate papers. They're not inclusive of, let's say, indigenous perspectives or tribal perspectives or native perspectives on climate and the environment. They're not inclusive of real lived experience of people in urban environments. And so one of the things that we've done is actually, we've developed there's a process called instruction fine-tuning, and so you can teach a model how to respond. And so what we've done is create a process to allow anybody to create their own IFT data set that is more representative of their lived experience or their research or their data. And so what we've done is we've actually worked with students in the UAE, we've worked with inner city youth, we're working with indigenous leaders to try to bring in their perspectives to inform this model as well, so that it's not just like a predominantly Western white UN perspective on climate, which is, they have a lot of great information, but it's not the most inclusive. And so there's biases there. There's biases in terms of just the compute, which I know we'll get into inclusivity, but we search the whole world to find the most sustainable compute to power these systems, and it's very hard. We used solar, we used wind. I think we found the only centers that actually have them. And so that, I think, is a bias also, just in terms of like, it's weird to train a climate model with dirty energy.
Yeah.
So.
Well, let's dive into this because we talked about it sort of ahead of this conversation on stage, and I thought it was one of the most interesting things you talk about, which is that there's inclusivity issues both at the hardware and the software levels, globally, so geographically, languages, you touched on languages. Like, how do you all think about this? Where are we now, and where do we need to be for this technology to really reach its full potential? I'll start with you.
Oh, that's such a good question. Where do we start? I mean, we already started, I guess. So the technology needs global reach. There were conversations happening earlier today that 20+ million American households do not have access to internet or will lose access to internet if they lose the funding for this appropriation that they had before. The same goes for the rest of the world. There's parts of the world that are just not connected. And so when we're talking about building the technology for everybody, bringing multidisciplinary stakeholders together, building these technologies for the benefit of communities all across the world, we do always have to remember that there's infrastructure gaps that need to be addressed first and foremost. And there's a lot of amazing work that's happening on that end, but it's also at risk. It's constantly at risk because everybody's always weighing priorities. And the interesting thing specifically is in countries that actually don't have as much connectivity or don't have as much connection as we want them to, are the ones that are the most optimistic about this technology. And the climate cases that you're talking about, or the agriculture cases that we're talking about here, they really can be quite excellent in places that generally climate change is changing the way things are working there. And so it has really detrimental effects on agriculture. And we did the Slama Impact Grant and continuing to work on that, but many different applicants from across the world, including the Global South, applied to show the use cases of how they can take llama and use it for food scarcity issues, climate issues, education issues, and having that pocket tutor in your pocket is such an important thing for us to start thinking about from an education perspective as well. So those are we're just beginning to scratch the surface of this problem.
Malo, how do you think about the public, what's the public-private partnership angle here? Like, what are you looking for from research and academic institutions working with industry?
Yeah, I mean, I'd even maybe zoom that out a little bit more of the question of, from my and Miri's perspective when we're thinking about this and kind of the ultimate long-run trajectory, I think these technologies are going to be powerful enough that we're likely going to be radically transforming all of society, and this could be happening in the next, 10, 20 years. And so it has to be something that I think we can't just have pockets of people developing the technology and steering kind of the course of that radical shift in the world. And we've got to really look, at the, local level, at the state level, at the federal level, at the international level, how we actually get all the important players to be cooperating to figure out how to deploy these technologies in a way that gets us the robustly good outcomes and ensures that we have the proper coordination to ensure that the misuse challenges we talked about, stuff that we haven't really got into that maybe this isn't the right panel for, that I also worry about with some of the loss of control, big picture issues when we have very powerful intelligence systems. How as a society can we actually, in the most kind of robust representative way, harness those technologies, ensure they're developed in the safe way, and that they're deployed to actually get the promise that they actually hold.
So how does an organization work with an organization like Meta at this point? Is there a path forward with it? Where do you two intersect?
I mean, it's probably not the best question for us. Miri and its world over the last 10 years has been doing kind of a much more high-level theoretical type research, looking at the properties we want for these very intelligent systems, trying to run ahead there. Yeah, I mean, I think it'd be interesting to hear from Paulina about as companies like Meta and OpenAI and Google are developing these much more powerful systems that I think will be extremely influential on the course of society, how they partner with the rest of the world to deploy and benefit those technologies.
So a couple of things. One, we with IBM here, we're one of the founding members of the AI Alliance, and the AI Alliance is hundreds of organizations across the world. It is a public-private partnership between many different organizations that are seeking to identify the benefits of open source and open innovation technologies, putting tooling into the world to address the needs of the risks within the space, and also contributing to the development of the technology overall. So that's one public partnership that we have, public-private partnership. We also run a program called Open Loop, which is a policy prototyping program. And these are programs all around the world where we work with different startups and governments in testing, creating test beds for the policies that policymakers are proposing, and then testing to see if they're actually possible and how they can be amended to make them more usable and scalable by organizations. We also do community fora where we engage a lot of the community that use our products to understand what are the benefits of the technologies that they see, where are their gaps, how can they be addressed, how can we close trust gaps. We have public-private partnerships all around the world right now, and with Llama 2 there's actually been an enablement of this all around the world because we've also connected to so many different organizations that are actually using our large language model to advance their goals, and we've seen incredible use cases in the medical and in the environmental and the education space specifically.
I'd love to talk more about education for a moment since we're up here. Thinking about, I mean, I have two little boys. They are 12 and 9. I think about that. I'm getting older every time I think about them. And this is not something that they're talking about in school, or like at least in their public school system, like AI and sort of preparing for thinking about how AI will impact their work and their jobs and their lives, and and the equity questions around AI. It's not there yet. So I'm wondering whether you all think about what do we need to do to equip students today with the skills to be able to harness this technology in the future?
I mean, I could start. So first of all, the technology can be fine-tuned for educational purposes. And so right now, of course, we're seeing alignment issues and we're seeing some models are able to hallucinate, but you can adjust the levers on helpfulness and safety. If you want your model to be the most safe and less hallucinatory, then you just adjust the type of weighting that's possible. And then you can use the technology for private tutors and for expanding the ability for people and personalized tutors as well, so that a child can understand, like if they don't need help with math, but they do need help with history, and the model will eventually know how to teach history, let's say by example, so that the kid can actually learn it. So I think there's a lot of opportunity in the actual already existing technologies, and we've seen a bunch of these use cases spin up already. My kids really are very much engaged in the AI space. So I have a 4-year-old and a 6-year-old, and actually my primary use case of Meta AI is with my children, because they ask me the wildest questions every single day, and I do not know the answer to these things. Like, how do monster trucks work? And like, how long is it gonna take me to get to the sun if I hop in a rocket right now? And so these are questions that I do ask Meta AI, and we have conversations about it, or we're like trying to decide what is a good family car. And we work together, and they're always like, Mom, ask your robot, and I'm always asking my robot. And I think like, this is not just like a cute story, but it's also just we as a society are starting to interact with these technologies in ways, and so we will need to teach our children how to do so responsibly as well. So there's a role to play for parents. There's a role to play media integrity organizations, civil society, school systems, and honestly us, the AI experts in the group, to be able to go and talk to schools about these topics. After we're done speaking with all the regulators and doing the capacity building there, we really need to hop into the schools as well.
Yeah, I mean, just expanding on that, I think you did a good job covering kind of like the applications in education, and then, to the last thing you were saying, I think there's just an important thing of having, more people, including kids, actually engaging with the technology. You know, I think it would be rapidly changing, and just actually having a better and better, deeper understanding of what it can do, what it can't do, what it's not good at, you know, where it's going, how that will affect society. It might all happen very fast, and I think people need to be engaged at the whole level, and especially, you know, the next generation that'll be building the future with this stuff needs to just be right in the middle of it and really understand it at a deep level.
Yeah, I would just say, again, this is where open innovation and open source tooling, I mean, I come from a Web3 background as well. It's how I started my career. And humanitarian technology often can seem scary to a lot of people. I spent, you know, time at the UN and teaching diplomats for years about how crypto works. And information is available and accessible, right? That's the power of large language models, actually, is that it synthesizes very complex information and makes it digestible. But also information regarding how these things work is also available. Now it's murky, and you know, someone earlier mentioned someone needing more translators. I've always kind of been a translator in my roles, but I think that that's one of the cool things about open source technology is that if you have an internet connection, if you have, you know, certain types of devices, you can start building, and you can actually, and that maybe that's part of the, you know, open source, and maybe that's the American dream, I don't know, but like I think that there's a lot of really cool things that don't require, the barrier to entry is lower. Now that's maybe harmful for, again, safety reasons, but I think for the most part, the information is there. I think things like Seed.ai are really great. I think there's like a hackathon thing happening next door that they're working on, which is just rapidly ingesting information and building a product. And so I think having more of a hacker mindset, I think in schools would be cool, to like have kids actually, instead of banning the technologies, they already have access to it. Like kids, I mean, elementary schoolers have smartphones these days, so like they're already actively using these tools. And so I think how we help young people, or anybody really of all ages, like my grandma, I'm teaching her about, you know, I already talked about crypto, she could tell anyone about it, but now I'm teaching her about AI. But I think
You do that for my own mother.
absolutely, it's once you know, what I think it was Einstein that was like, if you can explain it to like, you know, a 5-year-old or a kid, then you understand it, which takes time, but information is there. And so I think education is a really powerful tool for demystifying and for creating equity. So.
And that's actually an excellent use case for even just current models that exist, is just like try to explain this on a level of a 5-year-old, on a level of an 8-year-old, to my mother who is not exposed to technology as much. It's been very helpful.
So I want to leave a little space at the end for questions. So in about 5 minutes, we're going to open it up. Think about your questions now. Paulina, I do want to build on what you were talking about. Like, you know, you ask, we have a smart device in our house, and we ask it questions, and sometimes the answers that come back is not a Meta product, but don't worry. But the answers are puzzling.
Yes.
But it does raise questions about, you know, trust and credibility. And I think there was a KPMG report that came out last month that said a majority of people globally are, you know, having trouble trusting AI systems. You know, this is something we think a lot about in my world, because it's about, we are building this decentralized, trustless architecture for storage, where storage is verifiable and out there in the world and anyone can see it. So Ariana, I know this is a place where our worlds intersect, because you're thinking a lot about data verifiability in AI.
Yes.
How do you push back on these questions of trust in AI?
Yeah, so our core technology essentially allows each step of your training process, and really even, it can apply to non-AI training as well, but what it does is it creates a digital fingerprint at each step of your process. And so then what we do is we visualize that, we inject the fingerprint, the digital fingerprint, and then we visualize that process. And then we cryptographically, which is just advanced math, secure that verification or that signature or that credential, so you can know who approved a data set, who put in a data set policy, what computer, what data center and what hardware device, and was there a trusted encryption environment running, and what the runtime was, and what benchmarks were run, like truly at each step of the way. And again, happy to show people downstairs. But the way that works is that cryptography, we use certain open source tools for that and open source standards for that. With Filecoin, we actually, the way it works is that we store all of those cryptographic attestations on the Filecoin ledger, and the storage that we have every 24 hours, it audits and says, yes, we still have that data is still securely stored, and here's a proof of where it's stored, and you can see it. It has what's called a content identifier, and so these are all really cool, unique, open tools that we've combined so that you can trust when you're looking at something that it's true, and you can go in and you can click in and you can see whether or not something was verified or who verified it. And I think we see transparency as like a means to an end, the end being accountability. But with transparency, there's other tools that you have to kind of deploy. But I think, yeah. Those are some thoughts.
That's great. And Paulina, how are you thinking about this? Like, I'm sure you're in your role, you're working every day with policymakers to help build these levels of trust. So, like, what does that look like day to day for you?
Yeah, so for me, a lot of this does go back to transparency as a mechanism of accountability. It is true that 61% of Americans do not trust the technology. Some of the applications that are the most trustworthy ones are actually medical, and I find that really interesting because it's a very high-risk use case as well that has, high outcomes of potential harm as well. But people are so ready to have better healthcare in this country that they are really hoping that AI will help get them the answers they need about the common problems that they have. There's online therapists that can, given that AI can be a reflection of yourself and really just ask you some of those questions, could be really helpful. So I think it depends on what the AI is, but we've always been focused on transparency as a mechanism of trust. And I always go back to the 4 principles of explainable AI, which is a NIST framework that they put out at this point, I think 5 years ago, but that you need methods of transparency for different audience types in order for the transparency to land. So when it comes to ranking and recommender systems, for example, we at Meta, for a long time, people said well, the algorithm, and it's just the one algorithm apparently that was really just upsetting to people. But there's not one algorithm. There's very complicated AI systems that work together to deliver a ranking experience or recommender experience across many of our families of apps. And so we have many different forms of transparency. There's just the mere fact of helping people to understand that a particular product experience is powered by AI is level 1. Level 2 is decision level transparency. And we have a tool called Why Am I Seeing This? And you can click individually on each piece of content that you see to understand what was it about how you interacted with a platform that made you see this particular content. And then we have the next level up, which is AI system cards, which explains how these overall AI ranking and recommender systems work. And then we took the learnings from that and applied it to generative AI as well. So we have user-facing transparency within the tool. We have notifications on the limitations of the technology, that this is not all fact, that there can be misconceptions, that I am a large language model, I am not a person, I don't have opinions, I just say stuff. And then we have AI system cards for generative AI as well. And so hitting consumers at various different angles to make sure that we all start to speak the same language when it comes to AI.
All right, with about 5 minutes left, I want to open it up. Does anybody have any questions they want to grab you a mic?
There's a question right there.
I wanted to go back to, Mala, you very briefly mentioned open data, and I wanted to go back to that.
Sorry, I didn't hear.
Mentioned what?
Open data. Open data. So even, for example, the NIH, if you do NIH-funded research, you're probably gathering extremely sensitive data, but the NIH has a protocol by which outside researchers can be granted access to that data. And so I'm wondering, are comparable protocols coming up with proprietary data that's being used to train these models? And yeah, how's that coming along? And if it's not coming along, how can we make sure that everybody can still continue to develop these and we don't wind up with, oligopolies of models?
Throw it to one of you two. This is not my area.
So some of the work that we've done with Creative Commons, so if you're not familiar with Creative Commons, I would urge everyone to go and check in on their work. They do far more than just licensing, but they are working actually, specifically on climate, we're working with them on an initiative to approach climate scientists and climate publishers. So data sets are often gatekept by publishers, just for context. Like it's either NIH, which is, it's a health agency, that's a government agency, proprietary information, but also publishers, there's like a capitalist element to wanting to keep data for yourself, right? So you can just monetize it by journal subscriptions and paying for access. What Creative Commons is doing and what we're supporting them on is actually trying to go to publishers, and for those that are already open, we want to optimize those data sets to make them ready to train. So that's just kind of data preparation and cleaning. But then we want to go to folks and say, hey, if you open source your data set, sure, you may have to rethink your business model, but also you're contributing to solving a global problem that needs as much collaboration as possible. I think that there's other groups like the Allen Institute, so they're working on a ton of open source AI, but also open data sets. I think a solution is for folks to start generating their own data sets, right? Synthetic data sets are kind of its own hot topic issue, but there's a way to start aggregating data in a more decentralized and collective kind of data cooperative way that is also emerging so that you can fight the data oligopolies, which definitely exist.
I think we have one more question over here.
So,
Incredible. Roll on in.
question. So Mark Zuckerberg said that he wants to make open source AGI. A lot of people like Jeffrey Hinton have said that current AI systems are not an existential threat, but future AI systems, especially AGI, artificial general intelligence, might be an existential threat. Is Mark Zuckerberg talking about the same thing? Is he talking about something else? What does he mean by AGI and that we should open source it?
Yeah, I think those two statements are actually decoupled. It's like we believe in open source and we're trying to develop AGI. Those two things are not one and the same statement. So the things that I talked about today is definitely what we're much more about, which is doing evaluations, figuring out where are the no-go line decisions. We're not dogmatic about open source, and it will very much depend on it. Every model goes through individual review to determine whether it will be released and how.
We have one more question in the middle there.
Up. Fourth row.
Nope, there you go.
Hi there. So going back to Rachel's question about public-private partnerships, I'm interested in how you see all the different pieces of a project coming together, how we build from open science to technology. So you've got, thinking in along lines of physical sciences, fundamental quantum research, materials, astrophysics. How do you put together the pieces of funding, open sourcing data, producing the data, the compute resources, et cetera? Maybe you could give an example.
Yeah, so this is one of the reasons that at least at the current stage, we try to release as much of as many of the models as possible that we've developed so that people can test out those theories. Because if it comes to a large language model, for example, we train the large language model on large data sets. We release the large language model, and then people go in the research community and the developer community to prove out whether they can use it for these types of cases. So for example, in material science, you might be an entity that has access to materials information that we don't have, in which case you would then take the large language model, fine-tune it on the materials that are relevant so that the model can give suggestions about which types of two materials can be combined to achieve purpose X, and that way then the person can go into a lab and experiment with those two materials in a rather much quicker way. So some of the work that we did, and this is not Llama 2, but on DNA sequencing, for example, was like that, where using large language models for DNA sequencing was a very interesting way for people to do very quick testing that otherwise would have taken a very long time to achieve. And one of the unknown knowns actually is that the COVID vaccine, for example, they used large language models and different types of machine learning techniques to be able to very quickly do a lot of testing before they had to do testing in the test tube. So within the test tube, they were only had to test a smaller amount of sequences to tell whether the COVID vaccine will actually work against COVID.
And the COVID-19 the pandemic actually has accelerated open research significantly because the medical community found that in a time of global crisis, we need to not be paywalling research. And so I think that yeah, I just wanted to add that. But I'm happy to speak afterwards too. We did like truly a 6-month sprint using Llama 2 to create our climate model. And I can show you the whole training process.
Well, I think we're out of time. I want to thank my panelists. What a wonderful and inspiring moment to end on, which is like the power of this technology to solve global crises. Thank you to Seed AI for hosting us and to our wonderful sponsors.
Thank you to Rachel.
Thank you.